tomorrow I will late.
Don't be late. Simple.
I
What's
thought...
the first page? Can I see this? What is this?
But I thought the date is tomorrow.
Yeah.
So I can give it earlier.
Give it to me earlier.
Have
No.
to get this and fill it?
Cover sheet.
Why?
Sit down. You're making me tired.
Why not today?
Because.
Yeah.
But that's...
Because.
So we're all
Sit
supposed
down.
to be there at 9?
No, of course not. That's ridiculous. You're all supposed to be there before 9.
Yeah, so what's wrong with today?
I don't want it today. I want it tomorrow.
Today is before 9.
Yeah.
Mathematically speaking.
Why?
We need to staple this too, right?
Yes.
You must.
Yes. It's not stapled. It's unacceptable. I cannot accept this.
Why?
It's unacceptable. It's not stapled.
Do you have
No one has. That's the
No,
problem.
yeah, exactly.
Sylvia have?
Oh, but Sylvia's not.
Not you.
Oh, how funny.
Hey, Andrew, do you have something to stick together?
Stapler.
Stapler.
Ooh. Good.
Do you have it?
What? The stapler.
Stapler.
You want a stapler?
Stapler.
Well, why are you asking me? Like, do I look like a stapler?
No, do you have?
She didn't. I didn't want to say anything, but yeah.
He doesn't.
Why not today?
Tomorrow.
Why?
Because that's when I want it.
We can't submit it today?
No, I
What if I
want.
miss my bus tomorrow?
Don't do that.
What if the bus misses me tomorrow?
Take a taxi.
Why not today?
Oh my goodness! I will take it off you today if it's ready. But it's not ready. It's not. It needs to be stapled. It must be stapled. You get that stapled and signed. I'll take it off you.
I will use blue tack.
No, I won't take blue tack.
But it will stick together.
If I want it stapled, you must staple it. If I wanted blue tack, I will say blue tack.
Go on. Tomorrow, bring it completely stapled and give it to
But
me.
maybe tomorrow I will be late.
Don't be.
But maybe.
But don't be.
But maybe.
But don't be.
Blue tack.
I won't take it off you. Sit. Sit. I want to start. Hey. Where's Lee?
With Yahya, I guess.
Where is Yahya? With Lee?
With Lee.
Where's Wong? But Yahi and Lee.
Yeah.
They're in the library, I
I think they are.
They're in the ladies.
think. No,
Library.
Library.
They're printing something.
Who is this?
Not something. That's
Or someone. Ah, they're not printing the coursework now, are they? Because I'm not going to take it off them. Are they printing the coursework?
Mm-hmm.
Yeah, they want to print it for tomorrow, not now.
But they can't.
Fine, that's better. It's
You know
better.
what's really funny?
It's better if they're late now than tomorrow, so that's
Yeah.
fine.
We can't print it unless we have an account and we have to activate the account with the
Yeah.
IT support. Such a long process.
Why am I
Stupid.
doing that?
Because you were here before, so you
Yeah.
Why you know that?
Ah,
He has his ways.
yeah, I stalked you.
Yes, right, yeah. Yeah.
Wow.
It's all over the internet.
It's, yeah.
When I played with your drawing thingy, there was a hair. I took it and I took it.
It's voodoo, necromancy.
Alright.
Different things for personal things.
Can you write this down? This is the homework, so I just need these numbers. Do you have these? I can type them in, yeah? Okay. So we have milliseconds and microvolts. So this is time in milliseconds. Time in milliseconds. Volts in microvolts. And the time starts from 0 to 900, increasing by 100. Next, the voltage starts off with 500 microvolts, then 421, then, what's it?
354.
Next?
218. That's not.
298. 250, 210, 178, 149, yeah.
125.
105. Part 1. Graph this. So let's make the graph. Insert. Now, actually, first we have to log it. The T or the V?
V.
Yeah, so we'll do log V, which is in microvolts.
Didn't see your foot.
Poetic. Right. We have this? Yes? And we'll copy this down. So we don't actually care about this one anymore. So what I'll do is I'll just delete this.
It doesn't harm you to keep it there.
No, but my space is limited, so I'll delete it. Okay, insert chart. We have a scatter plot. We'll go this way, we'll go this way, we'll go this way. What's it called? Log, thank you. Log voltage against time.
Isn't it microvoltage?
Well, I won't put the units in the title, I'll put them in the X and Y. So the X-axis is time in milliseconds, and the Y-axis is log voltage in log microvolts. So I get this graph here. Let me just zoom out a bit or shrink it a bit. Okay, so this is what you should have. So part A, I've done. I've made the graph. So A is done. Let me just put a line on the graph here. A. Okay. Now, B. Estimate the tau, the time constant. So you should remember tau is minus 1 over the slope, which is minus 1 over, and then you choose 2 points on the graph and calculate it, as is normal. So you could write it as minus x2 minus x1 over y2 minus y1.
And I wanted to call it, that's why I wanted to do it in this one.
Yes, when you were in Cork, and I can see clearly you didn't watch the video.
No, I did. That's
Yeah,
why the value of the
If you watch the video, you notice I said something very bad about you during the video that should make you very angry.
It's fine. I
Okay.
gave up on you.
Alright, good. Okay, so I won't bother putting those points down because you can just see them yourself. For example, you could go with something like x2 minus x1, so that's 900 minus 100, which is 800, over 6.1 and 4.5. There's going to be different answers for everybody slightly because you have to read the graph. But the computer program gave me the exact answer, which I'll use, minus 0.0017, so this becomes 0.0017. There. No, I've already, oh yeah, in this case it'd be 1 over that, in this case.
Just 576.6.
Yeah, depending on, so you got 576, whereas I got 588. And what's the unit though? This is what we have to be careful about. Yeah, in this case, because we're using milliseconds, the unit is milliseconds. If you want to use seconds, that would be this. Okay, C. How long until the capacitor fully discharges?
Times
5 time constants?
283 milliseconds.
Yes, I probably have something similar. 2941 milliseconds, so about 2.91 seconds. D. What was the value of the resistor? Okay, so time constant equals RC. So the resistor is equal to the time constant divided by C, which will be 0.588, and the C is given in the question 100 millifarads. So that would be 0.100. So the answer is 5.88 ohms. Okay? E. Yeah.
If I changed it to 6, would that work? Or
Change what to 6?
is the resistance? Just say it's 6.
Yeah?
Instead of 0.58,
Yeah, instead of 5.88.
Round to 6?
0.6.
0.6?
No, it's 6.
Are you asking me, is it okay to round 5.88 to 6?
Yeah.
Or your answer rounded to 6 because of the earlier difference?
And it still end up with a 6. It doesn't.
Yeah, my answer would still end up with a 6.
I think rounding that to 6 is too much of a round. Yeah. Wrong. E. When will the voltage be 80 microvolts? So you have the formula voltage equals voltage at the beginning, E minus T over time constant. So we want to know when will this be 80 microvolts.
I want to complain.
Please.
Hunger is distracting.
Are you ready to continue?
No.
Thank you. V0, what's the voltage at the beginning?
No,
It's not 0.
it's 500.
The voltage at the beginning is 500 microvolts. The time is what we want, and the time constant, we'll put it into seconds, so the answer will be in seconds. It didn't matter about the micro because we can cancel the micro. So we'll do 80 divided by 500, and then we'll have to do a log here to cancel the E as well. So if I just hit that in on the calculator, it would be log 80 divided by 500. That's that number. That's equal to minus T over this. So if I divide by minus 1, I get that's equal to T over this. So I should bring this up to the other side. So I multiply this by 0.588. And after the algebra, I get T is 1.08 seconds.
Question.
Yes?
What is T over tau? Does it have any value?
I don't know. Maybe in court they can tell you.
No, seriously.
No, it has no meaning. It's
And the units cancel out.
yeah, exactly.
Cancel out or multiply because tau
Cancel, because T and tau are in seconds.
Yeah.
Their time. Yeah. Okay. F. How much charge is in the capacitor when the voltmeter is 80 microvolts? So we have the formula C equals Q equals CV, which is 100 millifarads times 80 micro. Yeah, that's it, isn't it? So that would be, let me see, 8 times 10 to the minus 1 times 10 to the 1 times 10 to the minus 6. So when you work it out on your calculator, you get 8 microcoulombs. Okay, G. What is the voltage after 1200 milliseconds? So the voltage after 1200 milliseconds, if we use microvolts, so I'll just write 500 micro is V0, E minus tau, which is 1200 milliseconds, so I'll put the time constant in milliseconds as well. And the other one, H, is what is the current? Okay, let me just calculate this. It is E power minus 1200 over 588 multiplied by 500, so that's 65 microvolts. And lastly, I want the current. So I think I'll use the triangle to get the current. Wait, do we know this? Yeah, we got it earlier, yeah. So the I is V over R, which is 65 times 10 to the minus 6, and what was the R? 5.88, yeah. So that comes out at 11.1 microamps.
Why microamp? Yeah, but 65 multiplied 10 to the minus 6.
Yeah.
How,
Well. Those Pringles better be for me. I don't want your half eaten Pringles, thank you. What?
Cheese and onion.
Oh, well, why didn't you say so? No, actually, why are you late? What happened?
We were printing since
Yeah,
the
even
IT
though
guys were at their job. Okay.
Only because I know that's a fact, I'm letting you sit down.
I can't.
what?
No! Blue hat.
Hey,
That's a kid.
That's my bag.
That's Chinese. Big happy.
Next lesson. I'm closing this for starting the next lesson, but this was the homework then.